Math 2, Unit 13, Section 2. So today we're going to talk about independent, mutually exclusive, and complementary events. Okay? So you'll notice that these are labeled on your notes. So we're going to talk about each of them separately and then all of them together. Okay. To start though, what is the probability of drawing a 3 or a 5 from a deck of cards? Now, we remember that when we see the word or, we're going to do what? Add them together. Now, it might be helpful sometimes to have your green sheet ready. But if you're looking at your deck of cards, which we have all of our cards laid out here on this sheet, how many 3s are there? 4. Out of how many total cards in a deck? Good. Okay. How many 5s? 4. Also out of 52. Now, whenever you're doing adding, whenever you have or, you need to always check for overlap. So I'm going to put or, always check for overlap. So can the 3s and 5s, can they overlap at all? No, if something's a 3, it can't also be a 5. So there's no overlap there. So all we do is add them together, which makes what? 8 out of 52. And then you always want to reduce if you can. Can these reduce? To what? What can you reduce by? 2 or 4? 8 divided by 4 is 2. 52 divided by 4 is 13. Okay, any questions on that first one? Okay, next one. What's the probability of drawing a 3 or a diamond? Okay, so how many 3s are there? 4 out of 52. And how many diamonds are there? 13. So if you look and we go down here, there's a total of 13 diamonds out of 52. Now, always when you are adding, check for overlap. Is there any overlap here? Okay, so just putting this up here so we can like visually see it. Oh, I don't have my highlighter. So we have our 3s, right? That was our 4. And then we have our diamonds. And as you can see there, this 3 I added with the 3s, and then I added that 3 again with the diamonds. But there aren't 2 3 of diamonds in the deck. So I just have to subtract out one of them. Now, some people in previous classes have said, well, if I know that I'm adding all the 3s, and then I'm adding all the diamonds, but I know that I already did that one, could I just put 12 here instead of 13? Could you do that? Yeah, definitely. So whatever makes the most sense to you, it's fine. You just need to always be thinking, is there overlap? Okay, and either by adding the whole thing and subtracting out the overlap or subtracting it before you even add it, either way works. So then we go through, and that makes what?
16 out of 52.
Good. 16 out of 52. And we can reduce that as well by what? By 4. And you end up with?
4/13.
Good. Okay, do we have any questions? Okay. Now we're going to specifically talk about mutually exclusive events. Okay, mutually exclusive events are 2 events that cannot happen at the same time. There is absolutely no overlap. Okay? And so if they tell you that they are mutually exclusive, you don't have to think about overlap because you know there is no overlap in mutually exclusive events. Okay? So on this one, when they say or, you're going to add the 2 together and you don't have to subtract anything. Okay? So again, remember that or means to add. And so if they told you the probability of A is 0.23 and the probability of B is 0.47, all you would do is add those together. 0.23 plus 0.47, and that equals 0.7. Okay, any questions? So what does mutually exclusive mean? Very good. They cannot happen at the same time. Okay, now, independent events. Okay, two events are independent if the occurrence of the first event does not affect the probability of the second event. Okay, but independent events can overlap. They don't have to, but they can. Okay, so events A and B are independent if the events of probability of A and B equals the probability of A times B. Remember that and means to multiply. Okay, independent events usually follow the rule for or is that you add A plus B and then you subtract out the and, which is where they overlap. Remember the probability of A and B, that is your overlap. Okay, so now we just want to try to give some examples of both types of events. So a mutually exclusive event and independent events. Can you guys think of any events that are mutually exclusive? Like there's no way there could ever be overlap. Say that again. Okay, so one of them would be rolling a dice or die. Good. Flipping a coin. Another one I was thinking about, like if somebody, like turning left and right. You can't turn left and right at the same time. Correct? Okay, now, independent events are events that could overlap. It doesn't mean that they have to, but they could. Yeah, so let's say specifically like drawing a 5 and drawing a heart. Okay. Complementary events. So complementary basically means the opposite. So if I said that the probability of you getting an A in this class is 40%, or I'm going to put 4 out of 10. Okay, what would be the probability of not getting an A?
6 out of 10.
Good. So the probability of not an A would be 6 out of 10. So you're always going 1 minus whatever the probability is for the not part. But you have to first know what this is. Does that make sense? So probability is just the opposite. Probabilities, there's always 100% that something's going to happen. Okay? So they're out of 1, and then the not part is the opposite of what would happen. Okay. So on these, we're going to basically say yes or no. For this first set, they ask you, are these mutually exclusive events? Yes or no? What does mutually exclusive mean? Good. Cannot have overlap. I'm going to put, or, yeah, no overlap. Okay. So, flipping tails on a coin or drawing an ace from a deck of cards. Can those overlap? So, are these mutually exclusive? I should ask that differently. Yes, these are mutually exclusive. Okay, drawing an ace or a diamond from a deck of cards. Are those mutually exclusive? No. Choosing a female high school student or a junior student? No. Because females are allowed to be juniors, right? Okay. No? All right. Determine if the events are independent. So independent means that there could be overlap. So we're going to do yes or no. Are these independent? Flipping a coin, flipping 2 coins one at a time, the probability of flipping heads on the second coin after the first coin was flipped. So independent events, they can sometimes have overlap or they cannot have overlap. Okay, but are these independent events? Yes. Yes, that's correct. So even if so sometimes there's overlap, sometimes they're not, but these are independent events. You remember independent versus dependent? Okay, these are still independent events. Okay, draw 2 cards with replacement. Draw a jack or a king. Yes, they are independent. Because it doesn't matter what you get, right? They are still independent events. So you draw 2 cards. One of them you draw it and you put it back. Could you still draw that card again? Yes. Okay, so we're thinking about independent almost versus dependent or mutually exclusive on these. Okay, number 6, is this an independent event? No, why not? Because you're not replacing it. So this is really a dependent event. So this one is no. Are we okay with that? Questions? All right. This next problem, number 7, they are telling you that they are mutually exclusive. Do we have to worry about overlap? No, because anytime it's mutually exclusive, you don't have to worry about it. You know there is no overlap. So, how would I find the probability of A or B? What would I do? Add. So, the probability of A, they told us, is 0.6. Plus, the probability of B is 0.25. We add those together, and what do we get? Very good. Okay, on 7, it says, what is the probability of not A or B? So what do we do to find that answer? We end up subtracting because we know the probability of A or B is 0.85. The not part is what would end up making this 1. So it's going to be 1 minus 0.85, which is 0.15. Do you see how the A or B plus the not makes 1?
Yes.
Okay, I should not see out cell phones. What are we doing? Okay, we should be focused on math. Okay, what's the probability of A and B? Normally with and we multiply, but in mutually exclusive events, can they ever overlap? So what's the probability of them overlapping? 0. Okay, yes. Right, they're not allowed to happen together. Okay, any questions? Can anybody explain it?
So number 9 and 0 because they since they're mutually exclusive, you won't they won't. Oh. I was just.
Okay. So there's no chance that A and B can happen at the same time. Therefore, you couldn't multiply them together. It's not happening. It's 0. Okay. All right. Now we're moving on to independent events. Can there be overlap in these? Yes. Okay. So what happens is when you're doing your OR part, and this is only dealing with when you're adding, you have to subtract out the overlap, and the overlap is your and. Okay? And so what will I do on 10? So I'd start by adding. Probability of C is 0.55. The probability of D is 0.4. And then we have to subtract out C and D, which is 0.22. They already did it for you right here. If you put that in your calculator though, 0.55 times 0.4, you would get 0.22. Okay, and so when you put all that in, what do you get? 0.73. So what is the probability of not C or D? What will I do? Good. 1 minus the answer for C or D, which is 0.73. And that equals what? Good. Okay, and then 12 said the probability of C and D. Yeah, they already did it for you. 0.22 is correct. Or if they didn't give it to you, you would just go 0.55 times 0.4, and it also equals the same answer. Questions? Okay. More independent events. Do you see on this one how they don't give the and portion? Remember that when you have independent events, you need to think about overlap. If they're telling us this, okay, we need to then go and find the and portion that we would end up subtracting out. So I'm going to go over here to the and first. How do I find the and portion? Good. 0.75 times 0.2, and what does that equal? Sorry. Good. 0.15 is correct. Okay, so now I can go to 13, and what do I do there? 0.75. Good, plus 0.2 minus 0.15. And what do you get? 0.8. Good. And then how do I find not E or F? 1 minus 0.8, which is good. Okay, this next one, you don't necessarily have to find the answers. They just want you to know whether they're independent, mutually exclusive, or neither. Okay, so on the first one though, you just want to check to see if things work right. So if I'm finding the probability of E and D, what would I do to find that? Multiply 0.7 times 0.2, and does that equal 0.14? Okay, so that checks out. And then here it says probability of E or D. So in order to find this answer, to check to see if it was right, I would have to go 0.7 plus 0.2 minus 0.14. And does that equal 0.76? Yeah, so that also checks out. So therefore, what is this? Independent. Because independent's where you have overlap. Okay. Do you see here how this says the probability of A and B equals 0? When does that happen? Mutually exclusive. And to double check, 0.23 plus 0.2, does that equal 0.43? Yes. Okay. All probabilities, when you have all the different outcomes together, what should it always add to be? 1. If this is saying the probability of M or N is 1.8, that should not even make sense to you because it can't be greater than 1. So this one is going to be neither. Okay, number 19, it tells you they're mutually exclusive. Do you have to subtract anything out on mutually exclusive? No. So what would you do to find this answer? Add 0.24 plus 0.38, and what does that equal? Perfect. 20. It tells you they're independent events. Are you going to have to subtract out something?
Yes.
Did they tell me what X and Y is? No. So we have to find the probability of X and Y first. Okay? How do we find that? Oops, I put that on the wrong line, sorry. What is the probability of X and Y? What do I do to find that? 0.09 times what? 0.6. And what does that equal? Good, 0.05. So now how do I find the probability of X or Y? Because you have to find that before you can find the not. Good, 0.09 plus 0.6 minus 0.05. Yes?
Why did you guys get rid of before on 0.05?
Normally we just round to the hundredths place.
Okay.
You could do whatever though. I mean. Okay, so 0.9 plus 0.6 minus 0.05, what do you get? .64? Good. And so then how do I find the probability of the not? 1 minus 0.64, which is 0.36 is your answer. Okay, 21. Is there overlap? No. This one they set up different. Do you guys know how you'll figure out what P probability of F is? Yeah, subtract. They gave you the or part. So all you're going to do, and is if you were setting this up, you would have 0.19 plus the probability of F equals 0.42. So you subtract 0.42 minus 0.19 and you get? Good. So probability of F equals 0.23. Okay, and 22. We're going to pretend that there's no overlap. It doesn't tell us this, but we're going to say they're independent events, but there's no overlap. So that means that we don't have to subtract anything. So what would I do if there's no overlap? Yeah, just the same thing again. 0.89 minus 0.75, and that equals? Good. So the probability of T equals 0.14. Okay, any questions?